Okay, thank you. Actually, I will need this computer. Yeah, thank you. All right. So I need to take this on stage here with me. So Lexon is a human-readable program language. And that has a lot to do with blockchain. It's inspired by blockchain, certainly. But it's not just for blockchain. Turns out, and we might speak about that a little later, that it's actually something that you can use for many different things. And as an example still, what I have here on the left-hand side, that's actually Lexon. And I will actually live code this for you. I know where I want to end up. And on the right-hand side, what you will see is how Sophia code is actually starting to appear while I'm writing something that is, in the end, something that's called controlled language, and hopefully something anybody who can speak English is going to understand, just like that. So in our example, we're going to create a very simple escrow contract. And that escrow contract has a payer, a payee, where the money should end up in the happy path case, and an arbiter that is going to decide whether the money should actually go there. So the way that you describe this in Lexon is that you say, okay, like in the normal contract, I first have a section where I'm defining what elements appear in that contract. And we have a payer, I just said that, and that is a person. And we don't know much more about this. When that person is then defined, when this template of a contract that we're actually writing here becomes a real contract, when it's deployed to the blockchain, and when it's instantiated, so to say, you will have to say what is the name, what is the street address of that person, what is the blockchain address of that person, and then you define it. But at this point, basically what I'm writing here is a template, and lawyers are used to that. Just the way they do it is usually a copy-paste style of doing it. They don't go from a template, they go from a contract that they did before and exchange the names that they have in there. However, the basic principle is known to lawyers, and that's important here. And that's actually a good example for where we're still working on this language, we're still making it better. We're still doing use cases, basically, trying stuff out, and then realize where it might be easier to do it another way. And in this case, this definition part, I think it's not even going to stay like this, but it's easy enough, hopefully, for everybody to understand. A programmer sees in this immediately, this is basically type definitions. It's a declaration, how we call it as programmers. For lawyers, it's the definition part. Now, the next part, and in this simple example, contract is just going to be, we're going to say, the payer is going to set all this up. We will say, for this example, it's a small one, if the payee doesn't like it, they're just not going to enter this contract. So we're going to say, the payer pays an amount into escrow. This is the money that, in the end, is going to go to the payee. Payer also appoints the arbiter. So basically says who is going to decide whether the money should actually go to the payee. The payer also appoints the payee, which is actually a good example where blockchain is immediately more powerful than anything we have in the real world, because usually the arbiter could run away with the money when they hold the money, when they control it. Not in this case. The smart contract automatically will lock in that the money can only go to the payee, nowhere else. And the payer also fixes the fee for the arbiter, that the arbiter will get. Now we're almost done. We just have the main functionality missing. We're just like, okay, what we want now is we want to say the arbiter is going to be the one who decides where the money goes. And the way that you write it in Lexon is you have a clause. The clause is going to call payout. And we say the arbiter may, well, first of all, they want to take the fee for themselves, right? The arbiter may pay from escrow the fee to themselves, and afterwards pay the remainder of the escrow to the payee. What I have now is the complete process, basically. You see that on the left-hand side, there's nothing that is something that you have to learn first how it works or have to go and learn programming for. It's also very easy to extend this. If, for example, this doesn't really make sense yet, you will also want to have a payback function, and all you do is basically go in and copy paste, and it's completely like common sense what happens, what you have to write here. If I would have done everything right, on the right-hand side you would see the Sophia coming up. I'm still looking at whether I did something wrong. Anybody can spot an error I made? Oh, thank you. Yeah, that might be one. It's not happy yet. I like this kind of. It should now show the code. It doesn't yet, so maybe we find another bug. But think about what just happened. Basically, what we can do to debug Lexon is we can tap into our normal speech system. If this was in C or even in Sophia, it would be pretty hard for somebody who never saw the language to find a bug. This was a bug. Maybe there's another one. But this is how you can, by collapsing normal language and programming, find problems in a much faster way. Because you're trained, you're using your language every day, you're finding bugs like this. Okay, I'm going to skip the rest of the debugging because basically it's here and this is what come out of it. I'm sorry, there's no I don't know what I made wrong, just typed wrong. But in the interest of time, we have to continue. What happens on the right-hand side, you see Sophia. We haven't done that. We're not quite there yet for Eternity. We have all this also for Solidity, which is just on this other tab here. And there we already have this button. We'll have this very soon for Eternity 2, where I can just deploy it directly to testnet in this case. And it's within minutes, it's on the blockchain, and you can actually use it. And there's even a interface where you can look at the contract and manipulate it. In this case, there are buttons for payout or pay back. if you're the arbiter, you can press these buttons and then execute this contract. Why is this important to have done in a different language? Well, we're going to talk about this now. Most of all, sorry, switching to our presentation. Most of all, we're going to talk about how lawyers actually see blockchain, how they see smart contracts. And this is something where we will also find that the whole word smart contract itself has been almost disowned by the community meanwhile, for reasons that actually Lexon is going to say, no, actually we claim that back. We think this is super powerful to be able to have smart contracts that are also legal contracts. And that has been the original motivation for me to start this project, where smart contracts per se can have this magic of shifting possession, like being able to send crypto from a sender to a receiver. But as long as you can be sued and somebody says, oh, well, yeah, sure, you get the crypto now, but actually I own it and I go to court and I sue you, smart contracts are not as safe as they could be. But if you join those two worlds of the legal and the technical, and you can come to a point where when you write the smart contract, you actually write both, the transfer of the ownership and the transfer of the possession, the one in the legal system and the other in the technical realm, so to say, then you have a real bulletproof contract. Because in many places in the real world, law will always trump technology. Maybe not for Uber, maybe not for Google, maybe not for Facebook, but for many normal businesses and for normal people, law will trump technology pretty often. So, yeah, with that said, we're here looking at the version that is being created right now for Aeternity, which I always like to say that Aeternity is on my radar because I really appreciate the strong engineering that's happening here. But now we're going to look at the quite far-reaching consequences that are coming in the picture when you manage to collapse the worlds of the legal world and the technical world. So with that, to Anja, and a little bit of an idea, to give you a little bit of an idea how lawyers think about smart contracts.
Yeah, so when it all started with the smart contract, what happened within the legal sphere was that you had lawyers that were saying, this is not a contract at all. And the problem was that whenever you send the funds to another person, for example, with the ICOs, what actually happened was that there were some terms and conditions that were creating this contract or contractual obligation from me to you. But the smart contract itself was just a program that executed a part of that contract. And in some jurisdiction, you would have a two-tier contracting system. So you have the obligations set forward in a contract, and then you had the execution part of the contract, which has little to nothing to do with how the contract is actually being written. And this is where the problem laid. So whenever you were speaking to lawyers, if they actually understood how smart contracts work, they could not understand how we can call that a smart contract. It was still a program. It was just like the word that you use on your computer. It was nothing else. It was just a code. And this is what's so funny about it. So when you first presented Lexon to me, we were in Berlin. It was a huge party. And we were in the deck of the ship. The party was going on. The music was very loud. And we were just geeking at the party, literally just opening up computer and seeing the code. And I almost cried. I mean, this is a revelation to me. Because whenever you spoke with the lawyers and they were telling you, yeah, but that's just the code. It does not really have the legal effects. What has the legal effect is the terms and conditions that we wrote before. And somebody pushed the button to agree with those terms. To me, that was a waste. Because a smart contract could have these types of obligations or these types of consequences. And the only thing that was missing was actually the programming language that would translate to lawyers, or that lawyers could co-create with the developers. And this is basically what's happening here. So when we saw the code on the right side, to the lawyer, it makes no sense to see .client and then comma or whatever. To me, that's unreadable. that makes no sense. It does not have any legal consequences. And even though it has consequences in real life, if I come to a judge, if I come to a lawyer with that kind of a contract, they're not going to understand it. So what really is needed is a Lexon programming language that shows you what it actually means and that co-creates the code by us just putting the orders in it. So yeah, that's one of the things. And then the other thing that we discussed previously was that we do quite a lot of copy pasting. That's true. We also have quite a lot of templates. And while a lot of contracts are looking like templates already, if they are simple, if they only have one single consequence or one variation of what can happen by those obligations being put in writing, then it's pretty simple to make a smart contract for it. While you do have quite a lot of tailored-made contracts, and with those contracts you can have a lot of different interpretations, a lot of different outcomes. So when it comes to those kind of contracts, it's going to be much harder to actually make a smart contract for it.
So it takes a bit of time to switch between, I just showed the code again, but I'm switching back to the presentation now. One of the aspects where smart contracts are usually, or one of the ways to look at how smart contracts can be employed is to look for cases where they are basically a subset, if you want, out of a much bigger master contract, which is actually something that is, there are terms for that. There is in trade the terms of schedule and the master contract, where whenever there's a new trade of oil or whatever it is, there's this master contract, and that's never changed. That's like thousands or hundreds of pages. And then there's a schedule that is what the actual good is that is varied around this time. Lexon can be seen to some extent as being used for this, where there's going to be a lot of prose that we call boilerplate, and we're going to come to that in a minute. And then there are the parts, and sometimes they may be small, that are actually going to be automized and that are actually going to go on the blockchain. The actual concept, though, is that hopefully you can articulate a lot of stuff in Lexon that is then going to be part on the blockchain, and the rest of it basically standing on its own, being there for the law, and in case it ever goes in front of a judge. So going through the slides here, this is basically summing up again what you just said. You have cases where you have high complexity, where you have a lot of variance. You have cases where you have low complexity, where maybe it's more likely that you're going to codify that and putting it on the blockchain. In the end, this is what the takeaway is, so to say, that lawyers tell themselves, one could almost say, right? Think of smart contracts when you're either embedding it into a larger context, or if the cases, the different cases that the outcomes might show are not many. Yeah, maybe you want to speak to that?
Okay, yeah, so the problem is that with blockchain you only automate one part, right? And this is where it lacks some of the capacity for lawyers. So just as you described it, it can partially be that we change how the law works or we change how the contract works, and we do that all the time. So when you say that there's a master agreement, this is pretty much, I mean, you might actually be familiar with it with different contracts. You can also have a contract of service agreement, and then at the end, there would be an Annex 1 or Annex 2 or whatnot, and it would schedule a work order. And this is what constantly changes while the contract stays the same. And this is perhaps what we changed already in the past, lawyers, but this is where I see Lexon comes in place.
So, in a way, if we talk about smart contracts in the bigger context of law, the question, of course, is a smart contract more than a program? Is it even intended to be legally enforceable? Or is it just meant as something where you have different strengths that come from the blockchain? And in this case, we have a quote here, a tweet from Nick Szabo, who coined the term of smart contracts, and who basically says, no, I mean, smart contracts, to quote him, aren't trying to create legally binding. They are doing, by other means, important functions, formerly done by trade contracts. This is exactly where Lexon comes in, basically, and proposes something where you can, in fact, have both. And it's interesting that Nick Szabo, for example, also, when he coined this term 25 years ago, I think, he was also proposing a language. That language, though, was a very formal language, more like a normal computer language, so he did not have in mind, and he also says that here, what Lexon does. Also Vitalik, the founder of Ethereum, has tweeted that basically he's regretting that he ever used this term smart contract. And thought was answering, yeah, stored procedures might have been more like it. But Lexon is basically putting forward exactly what the path could be, how we can join the promise that everybody hears in this smart contract, in this term, with the technical aspects that obviously have been quite successful, right?
Yeah, maybe there was another term, the Ricardian Contract, and what it basically meant was that we actually put the legal contract that we had into a machine-readable language. But what was missing at that point was, as you told me before, the programming language. So it was still a contract that was smarter in a way, but not as smart as we could make it with Lexon programming language.
Yes. So Ricardian Contract is what one might call the state of the art. I think a lot of successful smart contract management systems are basing their premise on that, where you have this way of braiding a combined hybrid out of a prose contract that is hashed, the hash is put on the blockchain, into a smart contract that's then giving a hash back that's put into the prose of the written contract. And so you have like those two worlds that read differently. The legal prose is going to be something completely different than what is on the blockchain, but they are, in a cryptographic way, made into one. Lexon is the next step, and actually the inventor of the Ricardian contracts, Ian Griggs, allowed as much. He said that Lexon was really taking it to the next level and doing something that Ricardian contracts kind of are running into a hard limit. Now, if we look at the history of smart contracts, it actually starts with Bitcoin code, because Bitcoin has a virtual machine, and every Bitcoin transaction is actually a very brief, small program. Nobody hand codes them, though. That's how they look. But this is where, for the first time, people got this idea how you could actually do a lot more with a multi-signature device that's as cheap as something that Bitcoin can provide you. Of course, this has been then developed further, and I think when we all really started to talk about smart contracts, that was with Ethereum, where Solidity looks like this. It is a lot more powerful. You can do magnitudes more with that than with this relatively modest Bitcoin transactions. But it obviously is made for programmers, and that's also what Vitalik says. He says Ethereum is made to empower programmers, and he was very successful with that, obviously. So what we're then proposing with Lexon, though, that's what I just showed in the live programming, is a way to have the same outcome, to have the same functionality on the blockchain, but have the input and have like a completely determinate path from this input to this functionality. Last weekend, we took part in the hackathon here for the Aeternity hackathon, and I proposed to start the whole thing like this, using a charter, using existing legal text, and start marking it up. In this case, you can see here that we marked up stuff that could be a functionality in blue, and what is boilerplate and would probably stay in the legal prose world in yellow. Now, the difference, I think, to other teams or to the usual hackathon experience in this case was that we really spent a full day doing this. And I wanted it that way, and I think that's a really important exercise, that we basically try to find out what's even legally useful to program into the contracts. And maybe you can give some of the details of what we're trying to do there.
Yeah, so you came to me with a proposal to provide you with a contract or something legal that you could then codify, put into Lexon. And cooperative is something that I'm very familiar with. So this is part of the statute for cooperatives. So it's not a law, it's not a regulation, it's actually something that a cooperative creates when it needs to be established. And it basically presents the rules for how someone becomes a member of a cooperative. Now, you should see the first draft that I made, because you kind of said to me, hey, we mark up something that you feel important and that you feel like should go to Lexon? So how we lawyers do the markups is we mark up everything that we deem important. And it wasn't at all like that. So the important yellow parts to me were those that you cannot really change, that you don't have the autonomy, like the parties usually have the autonomy. Those are the important parts to me. Those are prescribed by the law. So when we first exchanged our drafts, me and Marina, we were blown away because we saw for the very first time how developers do the markup. And how you do it, I think it should be created more often in the legal field as well, especially with the laws and the contracts, because when we do the templates or when we copy-paste the legal stuff, this is pretty much how it looks like. So the green stuff, for example, you can change. For each party, you can go and say, okay, instead of 60 days, we're going to have less days. And this is something that we usually would just leave a blank field. And then the blue part and the yellow part are right now becoming more and more interesting. So before I would never thought of, hey, we can actually make these parts blue because we can make our lives simpler. And all of a sudden, I have a lot of blue parts. And this is, for the very first time, very, very encouraging. I mean, it's changing a legal profession, not only making it a template that we can fill in with different parties and it's going to look like the same for all of them. This is actually going to be much more effective in terms of being automized in a way and being machine-readable in a way. So, yeah, I think after we did it for 3 or 4 times, I mean, we took quite a lot. These, at first, the statute had 54 articles, I think. And it all starts with, how you establish the cooperative. You need to set a name, you need to set a location, you need to set the director's name, etc. And then you go through the heavy parts. How is the governance of the cooperative going to look like? How are we going to vote? And this is something that to me is very interesting because currently, or for the latest year and a half, in the blockchain world, we're actually dealing with the DAOs. And what a DAO is, so far you look at the DAO stack, you look at the organ, and what they do is pretty much the voting. This is the governance that we lawyers put in the cooperative rules or the articles of establishment. Not necessarily a cooperative, but I usually compare those two. And when we went through all these articles, to me it became clear that DAOs might actually have these somehow incorporated already in the governance part. So whenever you create an organ or whenever you create a DAO stack, you already have it set up. You already know how the voters are going to vote, like they have reputations or whatever the cooperative rules could also establish. But this provides us new type of autonomy. This provides us the possibility that we have a set of rules that we incorporate, and not only incorporate like in legal terms, but also in the codifying terms, in the machine-readable terms. And we then merge these two words.
Yes, so, and in the hackathon we went on, we then tried our hand at creating Lexon. We limited ourselves. I mean, we really spent a full day doing all this markup with an existing charter of a cooperative. Then it became clear we won't be able to code all that in one weekend. But this is the goal. I hope we will continue working on this. And this is Lexon code now. This is the starting of just the registration of members, the administration of the director, and then that the member could leave and get a payout from their shares, actually. And the goal here is to have all of the stuff that has been marked up, no matter what color, rewritten in Lexon. The markup helps to understand how the Lexon has to be constructed because the blue stuff is what actually will go on the blockchain, and the yellow stuff is stuff that you don't have to articulate in Lexon and using any specific grammar because it's not going to be translated at any rate. So the exercise will be to come up with a complete version of this that has the same meaning in English, like the charter that we had shown in markup before, so that it could, at least in some jurisdictions, and we were focusing on a Slovenian jurisdiction for a start. We talked today
Not the
with
prettiest
Thomas.
one, though.
So Liechtenstein might be a stronger proposal here. But the idea is that you have a completely legal prose that you can read from top to bottom that at the same time can be translated and is the smart contract and is what is executed on the blockchain. It might go through a step where you create from Lexon, you create Sophia, and that's actually what we did. This is the corollary then in Sophia, but that's exactly what the Lexon compiler should do to you, and then the Sophia compiler compiles it to aeternity, so you have it on the chain. And in the interest of time, we're now closing this presentation, but in the end, what you want to have is an application that allows you to access the smart contract on the aeternity. And Arjan actually wrote that for us in the course of this hackathon, where you can then go and have a cooperative set up within minutes, because you just enter the name for it, you enter the first director, and you have the charter, because that is what it takes. And in Slovenia, maybe you would have to go and register it with a registration for cooperatives. And you would just take the original Lexon code there, and it does fulfill all the requirements. On the other hand, you have the blockchain smart contract that you deploy yourself, and then have the API, the GUI that actually allows you to interface with. Are we having time for questions?
Okay, so we are still over time, but because you guys are super interesting, and it's impossible not to open the floor for questions. So really quick questions, no back and forth, only one per person.
Yeah, hi, thank you. If I understand things right, you have a similar concept as open law does, right? You have a prose and parameters. That's their definitions. That's their approach. Are you familiar with them? No?
No. Yeah, I know open law, but it's really different because they really have prose and parameters.
Uh-huh.
And with Lexon, we have prose.
Okay, so you basically smart contract everything.
Yes.
The whole contract.
Yes.
Okay, thank you.
Thank you. Okay, one more question.
I have a simple question. Is it planned to have a two-way translation between smart contracts and lawful contracts?
Sorry, to have what?
A two-way translation, so that you can see the smart contract and get Lexon language out of it.
If the smart contract has been created by Lexon, yes, absolutely. I think deep compilation is super important to be able to prove to a judge that what is on the blockchain is actually coming from a certain source code, because going through the process of hashing it, and then you have to have the source code, otherwise you can't show what it actually is, because that's how it is in the moment. That's not going to fly. So yes, decompilation, if it's all in the Lexon universe, yes. If you just create any smart contract manually, so to say, to then translate that back into Lexon is going to be a very difficult proposition, because you're missing the level of abstraction, that is what is the power of Lexon, really. And Lexon goes from there down, and it allows you to articulate what you want on this higher level. While as a programmer, you have to, as a first step, always go to this lower level. But if this contract is written already in this lower level, it's very hard to add the higher level back in, because then you are in the realm of interpretation.
All right, thank you, Henning and Anja.
Okay.
That was
Thank
amazing.
you.
Thank you for the demo. I really can't wait to see where Lexon is in the next few years. It's really exciting.